Alright, I'm going to be talking to you about measures of variation, which include, in this video, we're just going to talk about range and interquartile range. So, the first thing you should know about this is anytime you have a data set and you're finding the range, the interquartile range, really almost anything about the data, put the numbers in order from least to greatest. So, in this case, we have a data set of 4. Each data set is going to get a little bit bigger than the one before. So, we have 24 points, cross that off. We have 29 points, that comes second, and then we have 31 points, that comes third, and then finally 38 points comes fourth. And we are trying to find the range. So if I find the range of this, all the range is the highest number in the data set minus the lowest number in the data set. So in this case, our highest number would be 38. The lowest number is 24. So we would just do 38 minus 24. And when you do that out, 38 minus 24 is going to equal 14. So you could say the range would be 14 points in this case. Now, once we have that done, we're going to be finding the interquartile range. And unfortunately, it's just not that simple. It never is in math, right? The first thing we need to do is find the median. Now, the median is not a measure of variation. I don't want to confuse you. The median is actually a measure of central tendency, which means it's a way of finding a center number in the data set. And so the center number here, if you recall, to find median, you just cross off the smallest number, cross off the biggest number, and you're finding numbers in the middle here. We have 29 and 30 in the middle. So your median would be right in the middle of 29 and 31, right? Because we would just add 31 and 29, and if you add those up, you get 60. And after you add those up, you would divide 60 by 2. And if you divide 60 by 2, you're going to get 30. Another way of thinking about it, this might even be easier. Just think to yourself, what's right in the middle of 29 and 31? Well, 30. It's 1 away from 29 and 1 away from 31. So your median here is 30. And your quartile 1 is what you need to find next. So Q1, it's a messy looking Q, but you get the idea. Q1, that's just the number. So we found the median here. It's at 30. This is where your median is. The quartile 1 would be, I'm going to do that in a different color. So that represents my median, this green little slimy strip. And the quartile 1 would be the median now of these two numbers, 29 and 24. So that would be right in the middle of 29 and 24. And again, you would add those two numbers up. They would equal 53. If you divide 53 by 2, you realize it's an odd number, so it won't go in evenly, but you should get 26 and a half. So quartile 1 would be 26 and a half. Quartile 3 in this instance would be right in between 31 and 38. And so that would be right here. And as you can probably see, they're 7 away from each other. So if you divide 7 by 2, if you want to think about it like that, 7 divided by 2 is 3 and a half. If that makes sense. 8 divided by 2 is 4, so 4 would be too much, too high. So 3 and a half added to 31 would be 34 and a half. That's like the middle of those numbers. So our quartile 3 would be 34 and a half. And then finally, to find the interquartile range, we would just do 34 and a half minus 26 and a half. And if you do that out, you would get 8 for your interquartile range. That would be 0, 34, we make that a 2, make that a 14. 4 minus 6 is 8. We get 8.0 for your interquartile range. And we can abbreviate that IQR. Let's look at another one. Text messages sent. So this is a data set with 5 numbers. Again, we put them in order first. So we would write 8. Cross that off. 14 would come second. And so you can see here the variation in numbers, you can probably tell, is pretty great. There's a big spread of numbers that we have. One day you sent only a few messages. One day you sent 62, so that's a lot of messages. So to find the range here, again, largest number minus the smallest. So it would be 62 minus 8, and that is 54 text messages in your range. 54 texts. And the next thing we would have to do is find the median. The median here would be 30. You can tell there's 2 numbers on each side. So 30 is right in the middle. The first quartile, well, This is our median now, so the only things that matter are the 8 and the 14. Right in the middle of 8 and 14 is 11, so that's our first quartile. Our third quartile is going to be right here in between 57 and 62. Remember, our median is 30, so we can't count that piece of information. Last problem, we could count the 29 and the 31 because they weren't the median. The median was 30, which really wasn't in our data set. But in this problem, the median is in your data set, so you can't count it. So it's between 57 and 62, and that number would be 59 and a half. And then finally, to find the interquartile range, we subtract, so it's 59.5. And remember, don't be confused with the decimals. If this number says 11 right here, we can make it 11.0 so that you can subtract this easier. My decimal just went away. So we would subtract 11.0. You got to add and subtract, follow the path. And 5 minus 0 is 5. Bring the decimal down. 9 minus 1 is 8. 5 minus 1 is 4. So your interquartile range here is 48 and a half techs. And that's a pretty big range of numbers. So you would say your variation is very spread out. Your distribution is very spread out between the numbers here. Alright, these are temperatures from October 17th through 22nd. Don't be confused by this. It looks like there would be 5 numbers, but if you really count the days out, 17th, that's 1, 18th, 2, 19th, 3 days, the 20th, 4 days, 21st, 5 days, 22nd, 6 days. There's 6 days there. So that's why we have 6 pieces of data. Again, put these in order from least to greatest. If you want to pause the video and try this problem on your own, I'm going to do the same thing. Find the range and then find the interquartile range. See if you can do it on your own now, and then you can check by playing the video once you've figured it out. Okay, so to find the range, I would just do 60 degrees Fahrenheit. I should have put my my units here. 60 degrees Fahrenheit minus 46 degrees Fahrenheit, because those are the greatest and least. So your range is 14 degrees Fahrenheit. The median, you'd have to cross off the numbers maybe in this one. It's a little bit harder to see, but you'll be left with 2 medians since there's 6 numbers in the data set. And the number that's in between 51 and 53 is 52. So we found our median. That's right here. Your quartile 1 is now just going to be between these 3 numbers. Since 51 is not really the median, we can include that in this data set here. So your median is actually, of these 3 numbers, your quartile 1, it's going to be right here at 48. And then on this side, your median of these 3 numbers will be right here over at 56. And then your interquartile range, you just subtract 56 minus 48. You get 8 degrees Fahrenheit. And you're probably saying, well, this is good. I'm understanding how to find this information. Why is it important? Why do we have to learn about this? Variation, think about this in terms of the real world. If you're a weatherman and you forecast the temperature every October, you're trying to see how much variation is there from day to day in the temperatures. That's an important thing because people, if there's a lot of variation, people are going to be changing what they wear. You know, maybe on this day you need a warmer jacket, but on the 60-degree day, you might even be able to wear like shorts. So weathermen want to be able to tell people how much variation they should be able to expect in the month of October. And they can kind of compare data year after year and say, well, our range of temperatures was 14 degrees. That's pretty significant. You know, things will change from one day to the next in the month of October. And looking at the interquartile range, that's a way of saying, well, the values that aren't so extreme, so 46 being kind of extreme because it's the lowest one, and 60 being kind of extreme because it's the highest one, the values like 56 and 48 that are less extreme, which is what we took here, that's only 8 degrees Fahrenheit, so maybe it's not too different from day to day. And then looking back on this problem, the text message problem, we could say, you know, there's a huge variation in how many texts that I send on a given day. Maybe I send a lot more on Saturday, but you know, Monday you're kind of tired from the weekend and you're in school and then you get homework when you get home, so maybe you're not sending as many that day. And maybe your parents will base your cell phone plan, how many texts they allow you to send based on what you do on a given day. Or maybe your cell phone provider, let's say you have AT&T, they're going to charge you, they're going to say, oh, we'll let you send a lot of texts on Mondays since the variation here, you know, on Mondays is pretty much right around, you know, 8 or 10 text messages or whatever, but on weekends, let's really charge them a lot of money. So you can you can play with this data in a number of ways to make it useful in the real life.